Hello everyone. In this video I'm going to speak about balancing redox equations. Let's get started. Balance each reaction using the half equation or the half reaction method. What we should do here, we have to check the reactants and what has happened to them when they became products. First we have Fe2 plus, it became Fe3 plus by losing an electron. So this is representing the oxidation reaction. Mn, we have to check what has happened to Mn. What is the oxidation state for Mn in MnO4 negative? Let's break down the ion. So we have here Mn, we know that oxygen is -2, so -8. Go to the other side will be +8, so we have +7. Well, so we have here MnO4 negative, it is +7. It became Mn2 plus. So from 7 plus to 2 plus, so it gained 5 electrons. It's clear that this is a reduction reaction because the oxidation number has been decreased. Okay, so we have 5 electrons. We need to balance the electrons in the, so this is the reduction half reaction. We need to balance the electrons because the number of electrons produced from the oxidation should be equal to the number of electrons that will be used in the reduction reaction. Okay, so how we can balance the electrons? We can just multiply the first equation or the first half reaction by 5. So now the electrons are balanced. Next, we need to check the atoms that we have here. We have oxygen in the reactants, but we don't have oxygen in the products. How to balance the oxygen? We add water molecules on the other side. So how many water molecules should I add? It's depending on the number of oxygens. I have 4 oxygens here, so I will add 4 water molecules. 4 water molecules, because in the 4 water molecules I have 4 oxygens. Okay, but after adding water, I have here hydrogen. I have 8 hydrogens. It's very easy. I will just add hydrogen ions in the reactants here. 8 hydrogen ions, because I have here 8 hydrogen ions in the products. So I have here the hydrogens. Hydrogen is balanced, oxygen also is balanced, Mn is okay. Now we have to add the half reactions. Electrons will be cancelled out because the number of electrons produced from the oxidation reaction were used in the reduction half reaction. Now we need to add the reactants. So we have 5 Fe2 plus 8H plus MnO4 negative. These are all the reactants that we have, plus 5 Fe3 plus Mn2 plus 4H2O. The interesting thing that we can do now is to check the charge. The charge of the reactants should be equal to the charge of the products. We have here we have 2 by 5, so we have plus 10. We have here plus 8, so we have plus 18, minus 1, so we have plus 17 in the reactants. Here we have plus 15, plus 2, so plus 17 in the product. So my work is correct. The charge of the reactants is equal to the charge of the products. That's great. Let's move to the next equation. Sn2 plus, it became Sn4 plus. Sn2 plus, it became Sn4 plus. How this has happened? This happened by losing 2 electrons. Sn lost 2 electrons. It's oxidation. How I may know that if it is oxidation or not? You need to check the oxidation number. If the oxidation number increased, so it is oxidation. This is representing the oxidation half reaction. Okay, then we have IO3 negative. I plus 3 oxygens is equal to -1. We already know that oxygen is -2, so we have here -6. Go to the other side, it will be +6, so we have here +5 for I. So IO3 negative, it has changed to become I negative. We already know that this I is +5. It became -1, so it gained 6 electrons. It gained 6 electrons. This is the reduction half equation. Okay, so we need to check the electrons. We have here 2 electrons produced from the oxidation, and we need 6 electrons in the reduction. So we can easily multiply the first equation by 3. 3, this will become 6 electrons. So now the electrons will be cancelled out. And we have to now balance the atoms. We have here oxygen. So we need to add water on the other side. How many water molecules? 3. H2O, because we need 3 oxygens. What about the hydrogens? We have 6 hydrogens, so we'll add here 6H+. 6H+. Okay, let's check what we have here as an overall reaction. We have 3SN2 plus 6H plus IO3 negative. It's producing 3SN4 plus I negative plus 3H2O. We need to check the charge now to make sure that our work is correct, or if there is something wrong. We have here +6 plus 6, so 12 minus 1, so we have here +11 in the reactant. We have here 12 plus 12 minus 1, so we have in the product also +11, so our work is correct. Okay, that's it. This is how you can balance a redox equation. You need to split the equation into two half equations, oxidation and reduction. You need to check if you have the correct number of electrons in the oxidation and the reduction. Then you need to balance the oxygen. If you have oxygen and the reactants, then you have to add water in the products. Of course, after adding water, you will have extra hydrogens, so they will add to the other side hydrogen ions, and you'll just balance it out. As a final step, you can check the charge of the reactants and the charge of the products. They have to be equal to each other. And that's it.